Welcome to part 3 of the lecture series on the real numbers. In this section, we will cover opposites, absolute values, and inequalities. We will begin this section with the opposite and absolute value of a real number. We will start with the real number line. The integers -5 and 5 are opposites. The integers -2 and 2 are also opposites. In fact, we can find infinitely many pairs of opposites on the number line. Notice that -5 and 5 are the same distance from 0. This is also true for -2 and 2. Having the same distance from 0 makes these numbers opposites. Equally important is the fact that when two numbers are the same distance from 0, they have the same absolute value. The absolute value of a number is the distance the number is from 0. When two numbers are the same distance from 0, they not only have the same absolute value, but the absolute value is always positive. The symbol used to represent absolute value is two vertical line segments on either side of the number. We will use the absolute value symbol, and we will look at some examples. Find the absolute value of 5 and the absolute value of -5. The absolute value of 5 equals +5, and the absolute value of -5 also equals +5. It is very important to remember that the absolute value will always be a positive number, since we are talking about distance, and distance can never be negative. We will now look at some examples. Give the opposite and the absolute value of each number. Remember, when a number has no sign in front of it, it is a positive number. So when we take the opposite of 53, we get -53. When we take the absolute value of 53, that's going to be +53. Remember, when you take the absolute value of any number, the result will be a positive number. For the second one, the opposite of -10.5 is 10.5. The absolute value of -10.5 equals 10.5. The opposite of -7/8 is 7/8. The absolute value of -7/8 equals 7/8. The last one, the opposite of 0 is 0, and the absolute value of 0 is also 0. 0 is its own opposite, and the absolute value of 0 equals 0, because remember, the absolute value represents the distance the number is from 0. Example 2. Find the value of each expression. For the first expression, we are taking the negative of the absolute value of 12. We know that the absolute value of 12 is simply 12, and then we're going to take the negative of it, giving us -12. For the second one, we are taking the negative of the absolute value of -3. We have seen that the absolute value of -3 is 3. When we take the negative of it, we get -3. For the last one, we are taking the negative absolute value of 15 minus 4. This is just simple subtraction inside the absolute value symbol. 15 minus 4 is 11, so we are taking negative absolute value of 11. We know that the absolute value of 11 is just simply 11, and we're taking the negative of that, giving us negative 11. We will now consider the order of numbers on the real number line. We will use the following symbols to indicate inequalities. We will use the less than symbol, the greater than symbol, the less than or equal to symbol, or the greater than or equal to symbol. In our first example, we will use the correct inequality symbol to make the following statements true. Notice on the real number line that as we move along the number line from the left to the right, the numbers get larger and larger. If we look at the first example, -2 and -5, -2 on the number line is to the right of -5. Therefore, -2 is greater than -5. For our second example, notice that we have a 0 and we have 0.1. 0.1 is a positive number, and all positive numbers are to the right of 0. Therefore, 0 is less than 0.1. For part C, when comparing two fractions with like denominators, the fraction with the smallest numerator will have a lesser value. Therefore, 4/3 is less than 5/3. For the last one, when comparing two fractions with like numerators, the fraction with the smallest denominator will have a greater value. Therefore, 7/8 is greater than 7/9. We will look at another example. Decide whether the statements are true or false. For our first one, we need to determine if taking the negative of the absolute value of -2 is less than or equal to -2. This statement is true, since taking the negative of the absolute value of -2 is equal to -2, and -2 is less than or equal to -2. Remember, when you are using the inequality less than or equal to, it means that the left-hand side is less than the right-hand side, or it means that the left-hand side is equal to the right-hand side. In this case, the equal part is true. In the second example, we want to determine if taking the negative absolute value of 10 is greater than 10. This statement is false, since the negative of the absolute value of 10 equals -10, but -10 is not greater than 10. For our last one, we want to determine if 0 is less than the absolute value of 5 minus 5. This statement is also false, since the absolute value of 5 minus 5 is the absolute value of 0, which is equal to 0. But 0 is not less than 0. 0 is equal to 0, but it is not less than 0.